So this is 5.1, relationships within triangles. So mid-segments of triangles is going to be this one. So we're going to be talking about making mid-segments in triangles. So everything that comes up on the screen or I write down, you're going to also want to write down, and anything I say that you would like to write down, you're more than welcome to. So definition of a mid-segment of a triangle. A segment is a mid-segment of a triangle if and only if the segment connects the midpoints of two sides of the triangle. Okay, so if we're looking at this first one, this is the mid-segment, and it makes the two congruent sides. Because remember, if it is a midpoint, that means it sits in the middle, which means both sides, the left side and the right side, are congruent to each other. So we have this side being congruent to this side, and this side being congruent to this side. So then if we look at this next one, if I look at this, you can see the left side and right side of it are congruent. The left side and right side of it are congruent. Pick a different color. If we look at this one, the left side and right side are congruent. The left side and right side are congruent. And then our last one, left side and right side are congruent. Left side and right side of what it touches is congruent. Okay, triangle mid-segment theorem. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third and half as long as the first side. Okay, so basically it's a theorem. I'm going to have this big long length here. It's going to equal half of whatever this is. So if we multiply whatever that is times a half, it should equal my big length. Okay, so what are three pairs of parallel segments? So I'm going to try to find its outer side along with the side that's parallel to it, so the mid-segment that's parallel to it. So if I have this outside here, the mid-segment that's parallel to it is going to be this, because parallel means they never intersect and they run along next to each other. Okay, so then another set, say I pick this one here, the one that is parallel to it, that's a mid-segment, would be this one inside here, and then this outside one should run parallel to this yellow one. And remember, when you write parallel, you use your little parallel signs here. So we're saying RS is parallel to DF, which is one of the pink ones. ST is parallel to ED, which is the yellow one. And then the last pink one, TR, is parallel to FE. Do you remember special angles created by a transversal? What is the measure of angle VUO? So VUO is right here. Remember, U is your vertex because it's sitting in the middle. Okay, so I have my parallel lines and I have my transversal. Okay, those are corresponding angles. Corresponding angles should be the same. So the measure of angle VUO is also 65 degrees because they're corresponding angles. Now, the measure of angle VUN, I want this one. Well, it creates a straight line, so if I take 180 minus 65, I should get 115 degrees because it creates a straight line. Okay, in triangle QRS, TU and B are midpoints. Okay, so this is congruent to this. These are congruent, and these are congruent. What are the lengths of TU? TU, so this one, UB, and QR, big one out here. Alright, so we know, let's change colors, that if these are the same, that means if I cut 40 in half, it should give me those. So I know that this one is 20, and this one's also 20. I can do the same with this other side. If these are the same, that means if I cut 50 in half, I should get 25 and 25. Okay. Also, we learned that the small mid-segment should be half of whatever the big one is. So if I'm thinking UT here and I have this big one being 40, I can find UT by just taking half of 40, because that was one of the theorems we learned. So UT, or TU, is now going to be 20. Now let's do this one. This time I have 50, so I'm looking for UB. If I take half of 50, I should get UB. So UB is now 25. Okay, but the next one I need to find is QUR. Okay, but I said that this midsegment, I'm going to erase this stuff so we can see it. This is half of whatever this is. So we need to double it to get back to square one. So if I double it, 30 times 2 is 60. Now let's think backwards. So the half of that should be the midsegment. So half of 60 is 30. So we know that that's correct. So you just have to work backwards. Okay, geologist wants to determine the distance AB across a sinkhole. So this is AB represented the same in this picture. So we're going to have to think backwards again. So I know that half of DC, or half of AB, sorry, should be whatever my DC is, right? So if I multiply this side by 2, we know DC is 46. So now I'm doing 46 times 2. So AB is 92 feet. Make sure you label it. Okay, so you think backwards again. You have to double it to get back to square one. If we would have had 92, you just take half of it to get that mid-segment. Okay, if JK equals 5x plus 20, and NO is 20, so if I take half of JK, I should get NO. So I know my JK is 5x plus 20, and my NO is 20. So let's just solve this. I'm going to multiply both sides by 2 just to get rid of that fraction. Subtract 20. Divide by 5. So x equals 4, and that was all I wanted, was to find x. Okay, so we're going to do the same thing again. If I know what half of 41 is, it should equal x. So we just take 41 divided by 2, and x should equal 20.5. Okay, if I take half of this, I should get this. So if I take half of 4x plus 20, I should get 3x. So I'm going to multiply both sides by 2 again. Subtract 4x. And divide by 2. So x equals 10 in this situation. If I wanted to find out what those lengths were, I'd plug this x back in, plug the 10 in for x for both of those.